construction and working of crazy lamps. Let us see the construction and working of crazy lamp. Here we can see the skeleton part of the animated lamp and ball. The skeleton is composed of cylinders, spheres, triangles, lines and points. Primitives used here are triangular fans and quadrilateral strips. And the objects used here are lamps. Here we can see the animated view on left and skeletal view on right. Ball. Here we also see the animated view on left and skeletal view on right.
Now we will see the formation of sphere. Using the basic primitive functions, that is points, lines and polygons, we form a triangular fans and quadrilateral strips. Here we can see the sphere that is composed of quadrilateral strips, and for the formation of poles we use the triangular fans as shown. Now here we can see the whole sphere composed of quadrilateral strips and the triangular fans, the poles. The OpenGL commands used are GL triangle fan for triangular fans and GL quad strip for quadrilateral strips. Shading and smoothness for constructed sphere. The module light and materials describes how light and materials are used to decide the color and light intensity of surfaces. In this module, we will investigate how this calculation can be used to render surfaces. We will look at shading and smoothness. Shading is about the shades on the object itself, whereas shadowing is shadow cast on other objects. The left sphere shows us shading and the right sphere shows us smoothness. We can calculate the normal of each surface and use the normals from surface n-1 and n when we render surface n. This will give an acceptable smoothing if we have small surfaces or small differences in directions. We can use normals that are the average of the normals in the border corners. This is obviously better and more robust approach. Some effects of Gauss shading. From left to right, first sphere with a flat shading, notice the McBand effect. Second sphere with a smooth shading. Third sphere with a shading and a spotlight placed as a headlight on the observer, same with the smooth shading. All the spheres are, in addition to the headlight, lightened from a surface up and right. We can apply two strategies to improve the result. 1. We can increase the number of surfaces. 2. We can model the spotlight with a softer limitation. These effects are demonstrated as shown.
Formation of lamps. Drawing table lamps. Manipulating light, position and spots. This module describes the rendering and manipulation of simple table lamps. The lamps are completely constructed with quadrants. They have 4 manipulatable angles. Each of them can be manipulated directly by mouse actions. The lamp consists of cylinders, the foot, the 2 arms and the lamp shade. Each joint is marked with a sphere. Here we demonstrate the unshaded part of the lamp and ball. Let us see the movement of the lamp. In this, the lamp body has been made up of many cylinders. The head is formed of quartz strips and the sphere forms the bulb. The cylinders are connected in between by spheres, which helps in movement of the lamp. For the movement of the lamp's head, body and base, We must identify which lamp and which part of the lamp. We use the strategy that the lamps are numbered from 0 and the parts are numbered as 10 star lamp number plus part number.
We set up a spotlight that fits in the lamp shade. We light bulb to look lighted. We make inside of the lamp shade to look lighted.
The functions used for translation of the lamp are